Today, there's a new space race. China has already put astronauts on its own orbiting space station and landed robotic rovers on the far side of the moon.
China is preparing a new mission to the moon, and this time the target is the mysterious South Pole. Scientists believe this cold region may hold frozen water and valuable resources. But there is a race, and China could arrive before NASA. What will they discover there? And why is this icy place so important? The mission China wants to fly by 2030. China is developing a detailed plan to land astronauts on the moon before the year 2030. This effort is part of the China Manned Space Program and represents the country's first attempt to send humans beyond low Earth orbit. The moon is located about 380,000 kilometers from Earth. Missions to low Earth orbit travel only a few hundred kilometers above the planet. A lunar mission requires far greater energy because the spacecraft must escape Earth's gravity, travel through deep space, enter lunar orbit, and later return home. This greatly increases fuel demand and mission complexity. To manage this challenge, China plans to use a two-launch strategy. Each launch will use the heavy-lift rocket known as Long March 10. One rocket will carry the crew spacecraft called Mangha spacecraft. The second rocket will launch the lunar lander known as Lunar. Both vehicles will travel toward the moon on a trajectory known as Earth-Moon transfer orbit. After leaving Earth, the two spacecraft will approach the moon separately. The Mangha spacecraft will first enter lunar orbit. The Lunar lander will also enter orbit and move into position to perform a docking maneuver with the crew vehicle. Docking allows the two spacecraft to connect, so astronauts can transfer safely between them. The mission will carry 3 astronauts. 2 astronauts will move from the Mangha spacecraft into the Lunar lander. The third astronaut will remain aboard the orbiting spacecraft. This astronaut will supervise spacecraft systems and prepare for the return stage of the mission. After the transfer is complete, the Lunar lander will separate from the crew spacecraft and begin its descent toward the lunar surface. The lander must slow down using rocket engines while navigating the moon's rugged terrain. Sensors and guidance systems will help identify safe landing areas by detecting slopes, craters, and large rocks. Once on the surface, the astronauts will begin exploration activities. They will wear specially designed lunar suits that protect them from vacuum conditions, radiation exposure, and extreme temperature differences. The lunar environment presents several hazards. Fine dust known as regolith can cling to equipment and reduce mechanical performance. Micrometeorites may strike the surface at high speed. Temperatures also vary widely between areas exposed to sunlight and areas in shadow. Astronauts will use a manned lunar rover to travel across the landing site. The rover will allow them to reach locations farther from the lander while carrying tools and scientific instruments. During their surface mission, the crew will deploy research equipment, study geological features, and collect lunar rock and soil samples for analysis on Earth. After completing surface operations, the astronauts will return to the Lunar lander. The lander will launch from the moon using its ascent propulsion system and travel back into lunar orbit. There, it will reconnect with the Mangha spacecraft through another docking maneuver. The astronauts and collected samples will transfer back into the crew spacecraft. Once the transfer is finished, the lander will be discarded, and the Mangha spacecraft will begin the return journey to Earth. The final stage of the mission involves atmospheric re-entry. The spacecraft will approach Earth at very high speed after traveling through deep space. To manage the intense heat created during this phase, the capsule will use a technique known as a skip re-entry. The spacecraft briefly enters the upper atmosphere, rises again for a short period, and then performs a final descent. This method helps reduce thermal stress and improves landing accuracy. Although the mission plan appears straightforward when described step by step, each phase requires extremely precise engineering and coordination. Launch timing, orbital navigation, spacecraft docking, lunar landing, and safe return must all function exactly as planned. For this reason, nearly every major component of the mission must be carefully designed, tested, and verified before astronauts can safely attempt the journey. The rocket built specifically for the moon. China's plan to send astronauts to the moon requires a launch vehicle far more powerful than the rockets used for missions in low Earth orbit. Existing rockets in the Long March family were designed mainly for satellites, space station modules, and cargo missions close to Earth. These vehicles cannot deliver the heavy spacecraft needed for a lunar expedition. For this reason, engineers began developing a new heavy-lift rocket called Long March 10. A human mission to the moon requires a large payload capacity. Studies by Chinese engineers show that a lunar transfer mission needs a rocket capable of delivering at least 27 tons into the correct trajectory toward the moon. This payload must include a crew spacecraft, supplies, and propulsion systems needed for travel beyond Earth orbit. Because current rockets could not reach this level, a new launch system became necessary. The Long March 10 rocket was designed specifically to meet these requirements. Its main design goals include strong lifting power, reliable engine performance, and safety for astronauts. Human missions demand extremely strict engineering standards. Every component must operate correctly during launch because repair is impossible once the spacecraft leaves Earth. The rocket uses clustered engines to generate the required thrust. Multiple engines work together at the base of the vehicle. This arrangement provides greater power and also improves reliability. If one engine experiences a small performance issue, the remaining engines can still maintain stable flight conditions. The propulsion system uses kerosene and liquid oxygen as fuel. This combination is widely used in modern launch vehicles because it produces high thrust and stable combustion. Liquid oxygen serves as the oxidizer, while kerosene provides the energy released during ignition. Together, they generate the force required to lift a fully loaded rocket through Earth's atmosphere. Engineers also designed the rocket with different configurations. One configuration is intended for lunar missions. This version focuses on delivering the crew spacecraft and lunar lander into the correct path toward the moon. Another configuration is designed for missions closer to Earth. This flexibility allows the rocket to support a wider range of operations, which improves long-term efficiency for China's space program. A key challenge of the lunar mission architecture involves launch synchronization. The mission requires two separate rockets to launch different spacecraft. One rocket carries the crew spacecraft, while the second rocket carries the lunar lander. Both vehicles must travel toward the moon along carefully calculated paths. Timing plays a critical role in this process. Each launch must place its spacecraft into a very precise trajectory known as Earth-Moon transfer orbit. If the timing is incorrect, the spacecraft may arrive at the moon at different moments or at different orbital positions. In that situation, docking between the crew spacecraft and the lunar lander would become extremely difficult or even impossible. Orbital mechanics therefore plays an important role in mission planning. Engineers must calculate launch windows that allow both spacecraft to reach the moon within a specific time period. Small adjustments during flight can refine the trajectory, but the initial launch path must already be very accurate. The Long March 10 rocket is designed to provide the performance and precision required for these operations. Its engines, guidance systems, and structural design all support the demands of deep space missions. By developing this rocket, China gains the launch capability required to begin human exploration beyond Earth orbit. However, powerful rockets alone cannot complete a lunar mission. Astronauts also need a spacecraft capable of operating safely during long journeys through deep space. The spacecraft designed for Deep Space China is also developing a new crew vehicle designed to carry astronauts beyond low Earth orbit. This spacecraft is called the Mangha spacecraft. The name Mangha means dream vessel and represents China's goal of expanding human exploration deeper into space. Earlier, Chinese human missions relied on the Shenzhou spacecraft. Shenzhou was designed primarily for operations in low Earth orbit, including missions to China's space stations. These flights remain relatively close to Earth and require shorter travel times. Lunar missions present very different challenges because astronauts must travel much farther from the planet. Deep space missions expose spacecraft to stronger radiation, higher speeds during re-entry, and longer travel periods. Because of these factors, engineers needed to design a new spacecraft capable of handling these conditions. Mengzhou was created to meet these new requirements. One major improvement is the size of the crew cabin. The spacecraft provides more interior space than earlier vehicles, allowing astronauts to work more comfortably during longer missions. Additional space also supports the storage of supplies and scientific equipment needed for exploration missions. The life support system has also been upgraded. This system manages oxygen supply, carbon dioxide removal, temperature control, and humidity levels inside the cabin. Reliable life support is essential because astronauts must remain healthy during travel to and from the moon. The spacecraft also includes stronger propulsion and maneuvering capability. These systems allow the vehicle to adjust its orbit, perform docking operations, and prepare for the return journey to Earth. Precise maneuvering becomes especially important during lunar missions. because spacecraft must connect with the lunar lander in orbit around the moon. Another important feature involves the safety system used during launch. In earlier spacecraft designs, the escape tower was mainly responsible for pulling the crew capsule away from a failing rocket. The Mangha spacecraft adds more direct control over this process. Its systems can quickly detect a serious launch problem and activate the escape sequence. The emergency escape system was tested during a flight at maximum dynamic pressure. This stage of launch places the greatest aerodynamic stress on the rocket and spacecraft. Demonstrating a successful escape at this moment shows that the system can protect astronauts during the most dangerous part of ascent. Mangha also introduces a different landing approach for crew recovery. Earlier Chinese spacecraft usually landed on land using parachutes. The new spacecraft is designed for ocean splashdown. Water landings can provide softer deceleration and reduce impact forces on the crew capsule. They also allow mission planners to select larger landing zones in the ocean. After splashdown, recovery ships can reach the capsule and bring the astronauts safely back on board. This method is widely used by several space programs because it offers flexibility and safety during the final stage of a mission. The Mangha spacecraft is therefore designed to support a wide range of missions. It can carry up to 7 astronauts during operations in low Earth orbit. For lunar missions, it will transport a smaller crew while providing the systems required for deep space travel. Even with these advanced capabilities, reaching the moon is only part of the challenge. The next major step involves landing astronauts safely on the lunar surface and supporting them while they explore one of the most difficult environments in space. And the hardest part, landing on the moon. Reaching lunar orbit is an important achievement, but landing safely on the moon is one of the most difficult tasks in space exploration. For this phase of the mission, China is developing a specialized spacecraft called the Lanyu Lunar Lander. This vehicle is designed to transport astronauts from lunar orbit to the surface and later return them to orbit for the journey back to Earth. The moon presents an extremely harsh environment. Unlike Earth, the lunar surface has almost no atmosphere. This creates a near vacuum environment where air does not exist to slow objects or protect equipment. Without atmospheric protection, the surface is also exposed to strong solar radiation and energetic particles from space. Another hazard comes from micrometeorites. These are tiny pieces of rock and metal that travel through space at very high speeds. Even small particles can damage equipment or spacecraft surfaces. Engineers must design the lander and astronaut equipment to withstand these impacts. Temperature changes also create major challenges. When sunlight reaches the lunar surface, temperatures can become extremely high. In areas without sunlight, temperatures drop very low. Equipment must continue operating during these extreme changes. The terrain of the moon also makes landing difficult. The surface contains many craters formed by ancient impacts. Slopes and rocky fields are common in many regions. Some areas contain hidden depressions that are difficult to detect from high altitude. Loose soil called regolith covers most of the surface. This material is very fine and can shift under pressure. Because of these hazards, the Lanyu lander must carefully guide itself during descent. The spacecraft will use a combination of cameras, radar systems, and navigation software to study the ground below. Optical cameras provide detailed images of the terrain. Radar systems measure distance and help map the surface during the landing approach. Special software analyzes this information and identifies safe landing areas. The system can detect large rocks, steep slopes, and crater edges. If a dangerous area is detected, the spacecraft can adjust its position while descending. These automatic adjustments help reduce the risk of landing in an unsafe location. Before performing real missions, engineers conducted extensive landing simulations on Earth. Large testing areas were created to reproduce conditions similar to the lunar surface. These test fields included artificial craters, uneven terrain, and sloped surfaces designed to represent possible landing environments. Because gravity on Earth is stronger than on the moon, special systems were used to simulate lunar gravity. Engineers built tall towers equipped with steel cables and controlled lifting equipment. These systems supported part of the lander's weight, allowing the vehicle to move in a way that more closely resembled lunar conditions. After landing successfully, astronauts will begin their surface operations. Their tasks will include placing scientific instruments on the ground, collecting rock and soil samples, and studying the local environment. These experiments help scientists understand the moon's history and its geological structure. Astronauts will also use a manned lunar rover during exploration activities. The rover is designed to carry tools, research equipment, and collected samples. It allows astronauts to travel farther from the landing site while maintaining communication with the lander. This vehicle increases the amount of terrain that can be studied during the mission. Landing on the moon represents a major technological achievement. However, the mission cannot be considered complete until astronauts safely return to orbit and begin the journey back to Earth. What China already discovered on the moon. China's lunar exploration program has already produced important scientific discoveries through robotic missions. One of the most significant missions is Chang'e 6. This spacecraft achieved a historic milestone by returning samples from the far side of the moon. The moon shows a striking difference between its two hemispheres. The side that faces Earth contains large dark areas known as volcanic plains. These regions formed when lava flowed across the surface billions of years ago. In contrast, the far side of the moon appears brighter and more rugged. It contains far fewer volcanic plains and is dominated by highland terrain. For many years, scientists wondered why these two sides developed such different appearances. Robotic missions helped gather data, but samples from the far side were never collected until the Chang'e 6 mission. The spacecraft targeted a region known as the South Pole Aitken Basin. This enormous impact structure lies on the far side of the moon and is considered one of the largest craters in the solar system. The basin stretches roughly 2,500 kilometers across and extends several kilometers deep below the surrounding terrain. Scientists believe this basin formed more than 4 billion years ago when a massive object collided with the moon. The energy released during that event likely melted large portions of the lunar crust and exposed deeper layers of the moon's interior. The Chang'e 6 mission launched during the year 2024 and successfully collected samples from this region. The spacecraft drilled into the surface and gathered volcanic rock material before returning it to Earth for analysis. This mission became the first successful sample return from the far side of the moon. When scientists studied these samples, they found unusual chemical signatures. The basalt rocks contained a higher proportion of heavier potassium isotopes compared with samples collected during earlier missions. Potassium exists in several forms that differ slightly in mass. Under very high temperatures, lighter isotopes tend to escape more easily into space. Researchers concluded that the ancient impact that formed the South Pole Aitken Basin released enormous heat. This heat likely caused lighter volatile elements to escape from the region. The remaining material therefore became enriched with heavier isotopes. This chemical difference may explain why volcanic activity on the far side of the moon became much weaker over time. Another surprising discovery involved tiny structures known as carbon nanotubes. These microscopic tubes are made entirely from carbon atoms arranged in a cylindrical shape. They are extremely strong and conduct electricity very efficiently. On Earth, scientists usually produce these structures using advanced laboratory equipment. Researchers examining the lunar soil found evidence that similar nanotubes had formed naturally on the moon. The lunar environment helps create these structures through several processes. Micrometeorite impacts strike the surface at high speed and generate intense heat. These impacts can vaporize carbon material present in meteorites or in the soil. When this hot vapor cools rapidly in the vacuum of space, carbon atoms can reorganize into structured forms. Iron particles present in lunar soil may act as catalysts that guide the formation of these nanotubes. This discovery suggests that the moon may naturally produce advanced carbon materials under extreme conditions. Such materials could be useful for future space technologies. Carbon nanotubes have potential applications in electronics, sensors, and energy storage systems. If similar materials exist in larger quantities on the moon, future explorers might use local resources to manufacture equipment directly on the lunar surface. This approach could reduce the need to transport large amounts of materials from Earth and support long-term exploration efforts. China's robotic missions therefore provide valuable scientific knowledge while also preparing for future human exploration of the moon. The new space race for the moon's south pole. A new global competition is forming around one special place on the moon. This location is the lunar South Pole. Many space agencies now see this region as the most important destination for future missions. The South Pole may hold resources that could support long-term exploration beyond Earth. One major reason scientists care about the South Pole is the presence of permanently shadowed regions. These areas sit inside deep craters where sunlight almost never reaches the ground. Because they stay extremely cold, scientists believe they may contain large amounts of frozen water ice. This ice likely formed when comets and water-rich asteroids struck the moon long ago. Water is extremely valuable for space missions. Astronauts can drink it to survive during long stays on the moon. Water can also be separated into oxygen and hydrogen. Oxygen helps astronauts breathe, while hydrogen can be used to produce rocket fuel. If these resources exist in large amounts, future missions may not need to carry everything from Earth. Another important feature of the South Pole is the presence of mountain peaks that receive sunlight for long periods of time. Unlike most places on the moon, some of these high areas can receive sunlight during much of the lunar year. This steady sunlight could provide reliable solar power for equipment and research stations. China plans to explore this region through several upcoming missions. One of the most important is Chang'e 7. This mission will study the South Pole in detail and search for water ice. The spacecraft will include several parts working together. An orbiter will circle the moon and map the region from above. A lander will touch down on the surface and carry scientific instruments. A rover will travel across the terrain to study rocks and soil. The mission will also include a special hopping probe that can jump into dark craters where sunlight never reaches. This probe will help scientists study the coldest areas where ice may be hiding. China is also working with international partners on a future lunar base called the International Lunar Research Station. This planned station could become a center for science and exploration at the South Pole. The station may include power systems to supply energy to equipment and laboratories. It could also contain communication systems to connect the moon with Earth. Robotic laboratories might run experiments automatically for long periods of time. Astronauts may visit the station during future missions to conduct research and maintain equipment. Another important mission planned for the future is Chang'e 8. This mission will test new technology for building structures directly on the moon. One possible method involves using lunar soil as building material. Scientists are studying ways to turn this soil into solid structures using three-dimensional printing technology. If successful, future explorers may build shelters, landing pads, and research stations using materials found on the moon. China is not the only country interested in the South Pole. The United States is also planning a return to the moon through the Artemis program. This program aims to send astronauts back to the lunar surface and eventually build a permanent presence there. The South Pole is becoming the main target for many missions because it offers several advantages. The region may support long-term human activity. It could provide fuel for spacecraft traveling deeper into space. Some scientists also see it as a preparation site for future missions to Mars.